Ohm's law, we get a technical word is called resistance. From Ohm's law, we get a technical word that is resistance. Now, what is the resistance? 1 volt potential difference per unit flow of current through the conductor is called resistance. 1 volt potential difference per unit flow of current through the conductor is called resistance. We know the equation for the resistance. R is equal to V by I. R is equal to V by I. But what happened here is 1 volt potential difference per unit flow of current through the conductor is called resistance. Resistance is inherent property of all conductors. What are the example of conductors? All metals. All metals has resistance in it. That's why resistance is the inherent property of all conductors. So, conductors are called resistors. What is the function of resistors? Conductors are called resistors. What is the function of resistors? Resistors opposes the current. What is the function? Resistors opposes the current. This is one of the important point. What is the function of resistor? Resistors opposes the current. Now what is the symbol for resistors? This is the symbol for resistor, symbol of resistor. If we take arrow mark, it is called symbol of variable resistor. Resistor is changes. If we take the arrow like this, is the symbol of rheostat. This we can use while doing the practicals. Okay, resistance is the inherent property of conductors. So the resistors are called resistors. What is the function of resistors? Resistors opposes the current. Why? See the relation R and I. Which relation is there? Inverse relation is there. What is the relation? Inverse relation. R proportional to 1 by I. When the resistance is more, flow of current is less. If the resistance is less, flow of current is more. We can write like this also. What is the relation between current and resistance? Inverse relation. R is more, resistance is more, current is less. Resistance is less, current is more. That's why resistance is the inherent property of the object. Resistance is the property. Resistor is the device. Resistance is the property. Resistor is a divisor. Resistor is a device. Now the resistor symbol is this. This resistor resistance is changed. We can write the symbol. This is variable resistor. If we can take the diagram like this, it is called symbol of rheostat. Okay, now resistance, which has a resistance, is called resistor. That's why resistors, resistance means R is depends on 4 factors. Resistors resistance is depends on 4 factors. Number 1, length. Number 2, cross sectional area. Number 3, nature. Number 4, temperature. Now here we concentrate first initially 2. First you take the resistor resistance depends on length of the resistor. Now which relation is present? Proportional relation is present. When the length is less, resistance is less. Length is more, resistance is more. Okay? When the length of the wire is less, resistance is less. Length of the wire is more, resistance is more. So which relation is there? Proportional relation is there. That's why R proportional to L. The next one, the resistance is inversely proportional to cross sectional area. Cross sectional area increases, resistance is decreases. This is the cross sectional area of this object. This is the cross sectional area of this object. This object cross sectional area is more, so resistance is less. This cross sectional area is less, resistance is more. So what is the relation between the resistance and cross sectional area? Inverse relation. Length is proportional relation, area is inverse relation. You take these two, from 1 comma 2, R proportional to L by A. If remove the proportionality, we will get one constant, that constant denoted by rho. What it is called? Rho. Rho is equal to RA by L. What is a rho? Rho is called as specific resistance. Rho is called specific resistance. It also has another name. What is another name of specific resistance? Resistivity. Specific resistance also called resistivity. Now what is the unit of the resistivity? The unit of the resistivity is ohm into meter. What is the unit of resistivity? Ohm into meter. Now what is the definition of resistivity? What is the definition of resistivity? Unit length. Length is called how much? 1. Unit length and unit cross sectional area. Area is also how much? 1. Length is 1. Area also 1. Unit length and unit cross sectional area of resistor. Resistance is called specific resistance or resistivity. Okay, means what is the definition of resistivity? Unit length, unit cross sectional area of a resistors. Resistance is called as resistivity. What is the unit of the resistivity? Resistivity unit is rho. Unit is ohm into meter. The specific resistance symbol is rho. In some books, the specific resistance symbol rho is also taken as S. Why? Specific resistance starts with letter S. That's why we can write specific resistance or resistivity. The symbol either rho or S. Now let us see the specific resistance. Which one? Specific resistance. Now the specific resistance rho is equal to R A by L, but we can write this as rho is equal to R into pi R square L also. Now this is, what is the R? R is the radius of wire. What is the L? Length of wire. Let us take a wire. This is the length, but what about this one? Cross sectional area. What is the area of the circle? Area of the circle is pi R square. You take a wire. Wire cross section looks like which shape? Circular shape. That's why we can take the area is pi R square. Now this is the equation for the resistivity of the wire. This is for conductor. Here conductor is a wire, we can write this is the principle. Now let us take a wire or a sheet. Let us take a wire or sheet. If you take a wire or sheet for made by the same material, if a metal is taken as wire and other same metal taken as sheet, both resistivity is same, but resistance is not same. Okay, you take any wire or a sheet, both are made by the same material. If both are made by the same material, both resistivity is same, but resistance is not same. Resistivity is same, but resistivity is not same. This is one of the important point for the 2 marks. Now let us take a wire. Next one. If a wire is stretched, if the wire what happened? Stretched. If the wire is stretched, its length is increases. Length what happened? Increases. So that resistivity is not changed. Why? The metal is same, but resistance is increases. Why the resistance is increases? The length is increases, so the resistance what happen? Increases. Okay, this is very, very important. Next one, the stretched wire. The stretched wire length. The stretched wire length is increases n times. The stretched wire length is increases n times. Resistance R2 is equal to resistance R2 is equal to n square R1. Resistance R2 is equal to n square R1. Resistivity is same. Means resistivity rho 2 is equal to rho 1. Okay? If the stretched wire length is increases n times, resistance R2 is equal to n square R1. Next, the stretched wire area is decreases n times. What we can say? Area decreases when it is stretched. Length increases, but what about area? Area is decreases. Then what happened? Decreases how many times? N times. So resistance R2 is equal to n power 4 R1. N power 4 R1. Then what about resistivity? Resistivity is same. Means rho 2 is equal to rho 1. Okay, you must be remember these points. When the wire is stretched, the stretched wire length is increases, so resistance is increases. If the length is increases n times, means 2 times increases, resistance 4 times. Length is 3 times, resistance is 9 times. Length is 2 times increased, resistance is 4 times. Length is increased by 3 times, resistance is 9 times. Length is 4 times, resistance is 16 times. That's why what is the formula? N square R1, but resistivity is same. If the wire is stretched, the cross sectional area is decreases n times. Decreases n times, resistance is increases n power 4 times, and again resistivity is same. Okay, this is about the relation between resistance and resistivity.